In this video, I'm going to show you how to solve radical equations. So when I talk about radical equations, I'm talking about equations that have one or more radicals in them. So here are some examples. So let's get started. So here we have to solve the square root of x equals 6. Now when we solve these, we're going to be using our equation skills, but there are going to be a couple of things that we're going to have to do that are maybe a little bit different than what we normally have to do when we solve equations. So first of all, I'm thinking, how do I get x by itself? Well, the opposite of taking a square root, because I'm trying to get rid of that square root, would be squaring. So we're going to square both sides. And of course, if you have the square root of x and you square that, you're going to get x. And of course, on the other side, you're going to get 36. And it's pretty easy to see that the square root of 36 is 6, so easy to check this. And so that is our answer. Let's move on to the next problem. So this problem's similar to the other one, but we got that 2 there on the same side as the square root of x. Now, all we really need to do is subtract 2 on both sides, and we get an equation similar to the one we were just working with. Now, sometimes students will do something here that you can't do. So let's look at what we have here. If you tried to square both sides there, you might think that you'd get x when you square the square root of x, and 2 squared is 4. And then on the other side, when you square 10, you get 100. So it turns out that you can't do this, and the reason why is because when you square the left side, you have to square the whole side. And we would have to FOIL out 2 square roots of x plus 2. So we can't do this. So let me erase this. But we do know that we can subtract 2 on both sides, and now our equation looks very similar to the one we just did in problem number 1. So we'll square both sides, and here we get x equals 64. So there's going to be, well, let's do another problem. Example 3. So in this problem, you might be tempted to subtract 4 on both sides here, trying to get x by itself. But that 4 is underneath the radical, and I don't have anything that tells me I could subtract 4 when I have a number under the radical. I can't just pretend the radical's not there. So we can't do that. But what we can do is square both sides, and that'll get rid of the radical. And so we're going to end up with 3x plus 4 is equal to 25. And now I can get to the x. We'll subtract 4 on both sides. We get 3x equals 21. And then divide each side by 3, and we get 7. It's not hard to check these. Notice if I plug in a 7 for x, I have 3 times 7 plus 4. That's 21 plus 4. We're going to have square root of 25 there equals 5. And of course that's true, and so you can see that that does work. Let's go on to number 4. So once again, we talked about this before. If you have a radical, we might be tempted first of all to combine the 4 with the minus 2, but again we have that problem. The 4 is under the radical. We can't just pretend that that radical is not there, so we can't do that. But what we can do is get that radical by itself. And actually, notice what I did here. If you actually squared x plus, or the square root of x plus 4, you'd get x plus 4, and square the 2, you get 4, and on the other side square 1 and you get 1. This is a common mistake that students make. Again, if you were going to do this, you would have to square this whole side and square the other side, and when you do that, you're going to have to FOIL out 2 of those, and so we don't want to do that. We can make this problem much easier on ourselves. we can make it a lot easier on ourselves by just getting rid of that minus 2. So let's go ahead and add 2 to both sides. We get the square root of x plus 4 equals 3. And now it's just like number 3. To get to the x, I'm going to need to square both sides so I can get rid of that radical. I get x plus 4 equals 9, and so we get 5. And again, notice if you check that, 5 plus 4 is 9, the square root of 9 is 3, and 3 minus 2 is 1. That will check. Let's move on. So I had said there's a couple of things that you need to know when you're solving radical equations. And so there's really 2 things you want to remember. The first thing we've already talked about, we always want to isolate the radical on one side before we square each side. This is with equations that have just one radical. And most of ours are going to have just one radical. By the way, if you do have an equation with 2 radicals, you want to get the 2 radicals on opposite sides, and then you can square both sides. So we'll do that at the very end. The other thing that we want to remember, let's look at a problem first, and then we'll put that down. So consider the square root of x equals negative 9. So let's square both sides. We get x equals 81. However, if you plug that in, that doesn't work, because the square root of 81 is 9, not negative 9. So this is false. So 81 does not work. So here we have no solution. Now I just want to point out that if you think about when you take the square root of a number, what kind of numbers can you take the square root of? Well, you can take the square root of 0, and that's 0, because 0 squared is 0. We've talked about how you can't take the square root of a negative. Like the square root of negative 1 is I, and we would be into imaginary numbers. But think of it this way here. We can't take the square root. There's nothing we can take the square root of and we get a negative number. Whereas if we had something like the square root of 4, if we're taking the square root of a positive number, we're okay. Let's take the square root of 2. If you check it on your calculator, it's about 1.4. So we know if we took the square root of a negative number, we'd have an I, and that's not what we have here. And we know we can take the square root of 0, we get 0. We know that we can take the square root of a positive number. So anytime we have a situation like this where the square root of something is equal to a negative number, we know that this is not possible, and so we're going to have no solution in this situation. So if you see this case, you can just write no solution. Otherwise, you go through the process and you just want to make sure you're checking your answers so that you'll catch it if you don't catch it to start. So the other thing I want to make a note of here is you always want to check your answers with these. In number 5, it's pretty easy to tell that there isn't a number you can take the square root of and get negative 9. But sometimes it's not so obvious. Let's do another one. And let's see, so in this problem we certainly want to get the radical by itself, so let's subtract 8 on both sides. So look at what we have here. The square root of something equals negative 6. So if you were paying attention here and you saw this negative 6, you know that this has no solution, because we can't have the square root of a number give us a negative number. However, we could go through the process of solving this. So square both sides. We get 2x plus 5 equals 36. Subtract 5 on each side. Divide by 2. We get 31 over 2. Let's go ahead and plug that in. So let's see, 2 times 31 over 2, that's 31, plus 5, It's going to be the square root of 36 plus 8. That's 6 plus 8 equals 2. And we know that's not true, that's false. And so you can see that it doesn't work. And so in this case, our answer is no solution. So we could have stopped right here and said, hey, there's no solution because the square root of a number can't be negative 6. We don't have any situation where we ever take the square root of a number and we get a negative number. Alright, let's move on. Now, on numbers 5 and 6, you could tell very early that there was no solution. A lot of times you'll have a situation like we have here on number 7. So notice here we've got the radical by itself, so we can go ahead and square both sides. And so we're going to get x squared equals 2x plus 8. So this is a quadratic equation. Let's get 0 on one side, everything else on the other. So I'm going to subtract 2x and 8 from both sides. I get x squared minus 2x minus 8 equals 0. So this is a quadratic equation, and we can solve this by factoring. So we need two numbers that multiply to negative 8. Whoa! Negative 8 and add to negative 2. And that would be 2 and negative 4. So notice because this is a 1x squared, we can just plug those numbers in. We're going to get 4 and negative 2 when we solve that. Now I want you to notice for the negative 2, if I plug in negative 2 for x here, notice we have a negative 2 is equal to the square root of 4. Well, we know the square root of 4 is positive 2, so this is false. And so we've got to throw out the negative 2. You can check 4, but 4 does work. So notice here one of our two answers doesn't check, so there's just one solution. So it's not going to be no solution just because one of our answers didn't work. It's very possible that one of them will. Let's move on to number 8. So here again we've got the radical, we need to get it by itself. We've got to get rid of that 4. So we're trying to isolate the radical, we'll subtract 4 on both sides. Now you got to be a little bit careful here. Sometimes on the right side students will write x squared minus 16 or plus 16 when they square both sides, but that's wrong. Because here's the thing. When we square both sides, we're squaring the whole side. And so this is FOIL in disguise. On the left, we're going to get 2x plus 7, but on the right, we're going to have to FOIL out 2x minus 4s. So I'm going to go ahead and do that here. So you can check my work, but if you FOIL that out, you get x squared minus 8x plus 16. So this is a quadratic equation. I need to get 0 on one side, so let's get rid of the 2x and the 7. So let's see if we subtract those from each side, we get 0 equals x squared minus 10x plus 9. So we need to find some factors, two numbers that multiply to 9 that add to negative 10. Negative 1 and negative 9 are what's going to work here. And we can take the shortcut here. We're going to get x minus 1 times x minus 9. So 1 and 9 are my solutions. Now again, let's go ahead and try 1 here. Check 1. So 2 times 1 plus 7, that'll be the square root of 9, which is 3. So is 3 plus 4 equal to 1? Certainly not. That would be false. And so we'll throw out the 1. And in fact, if you check the 9, it does work. Just to save some space here and some time, I'm not going to do that. I'll let you do that, but it does work. Number 9. So this one looks kind of difficult, but in fact, because we just have a square root on both sides, let's just square both sides. So we're going to get 2t minus 7 equals 3t minus 12. So these are actually quite easy to solve. Let's go ahead and get t on one side. And we'll have to add 12 to both sides. and we get t equals 5. If you check that, you'll see that this does work. Let's see, 10 minus 7, that's square root of 3. And 15 minus 12, we're also going to get square root of 3 on the other side. So that is equal, 5 is our solution. Alright, let's do one more, but let's do one this time where you have a radical on both sides, or you have two radicals. So in this problem, the radicals are already on opposite sides, so I don't need to move one of them, but I do need to go ahead and square at this point, so let's go ahead and do that. So we're going to get x plus 8 on the left, and we've got some work to do on the right. We're going to need to FOIL out two of those square root of x plus 2's. So square root of x times square root of x is x. The square root of x times 2 is 2 square roots of x. We've got another one of those for the inner product. And then our last product, 2 times 2 is 4. So notice we got some like terms here. Let's combine those together. If you have 2 square roots of x and another 2 square roots of x, that makes 4 square roots of x. So let's go ahead and put this in now into our equation. And so notice we still have a radical. So this is, in this situation, you end up having to square both sides twice. But before we do that, we've got a lot of work to get that radical by itself. So let's go ahead and subtract x on both sides. That's going to work out nice. And we want to get that radical by itself, so let's also get rid of the 4 there. We get 4 equals 4 square roots of x. Again, the radical is not by itself, so let's divide by 4. We get 1 equals the square root of x. And so you get x equals 1 when you square both sides. And if you check that, you'll see that it does work. Okay, and that's it for this video.